Hello, algebra students. Here we are with another flipped lesson, and this one is going to be on solving two-step equations. Now, I'm expecting you already know how to do this. These shouldn't be that difficult, but I will go over it, and we have to have this mastered. So take this serious. We'll probably spend a day or two, or more than a day, on this, because you have to be an expert at this. Now, you see this funny word here, the Saddam word. This is the way I teach how to remember what to do. You know the order of operations, and we go parentheses, exponents, multiplication, division, addition, subtraction. Written more traditionally, you would see something like this. And notice I'm trying very hard not to call it PEMDAS. It's the order of operations. Well, if you read backwards, you notice that it spells S-A-D-M, or I like to call it Saddam. We are going to listen to Saddam when we go to solve these problems. Okay, but before we do that, we need to ask ourselves a couple questions. And I'm just going to use a real simple equation here, like 2x plus 1 equals 9. And I know a lot of you can do this in your head, but we have to get these basics down so that we can do the more difficult problems later. The first question is, what is my goal? What is the goal? My goal is to get out of draw mode. There we go. Where's my mouse? I can't find my mouse. There we are. All right, what is my goal? All right, well, hopefully you all know that your goal is to get x alone. So your goal is get the variable alone. Okay, we want it to read x equals, y equals, q equals, any variable that you use. By the way, there's only one variable you can never use. Hopefully you realize the only letter you can never use as a variable is an O, because the readers can't tell if it's an O or a 0. All right, so the next question is, what numbers are keeping the x from being alone? Alone. All right, what numbers are doing that? Let me put that here. And in this problem, we have to stop and realize that there are two numbers keeping it from being alone. And they are the 2 and the 1, right? Okay, time for question number 3. Okay, how are they attached to the x? And what I mean by that is, what operations are attaching them? Okay, what operations are attaching them? I can't find my mouse. Mouse, there you are. Okay, and in this case, the 2 is attached by multiplication, the 1 by addition, right? Okay. All right, next question is how, oh no, what's going on? How, it won't let me do it. How do I undo those? I have to use the inverse operations. What are the inverses? How do I undo those? Well, to undo the inverse of multiplication is division, and the inverse of addition is subtraction. All right, so the final question you need to ask, and hopefully you guys are masters of this, the final question I have to ask is, which do I undo first? And that is where Saddam comes in. He tells me to undo subtraction and addition before I undo multiplication and division. And technically, I can do it other ways, but kids make lots of mistakes when they don't follow this algorithm. All right, so my goal is to get the x alone. I'm going to circle the x. I know I've got a 2 attached by multiplication, a 1 by addition. I'm going to undo. So my Saddam tells me to undo the addition first. So I'm going to undo the addition by subtracting, and I subtract the number that was attached by addition. If I do it to one side, I must do it to the other. Now look, if this is difficult for you, you want to come up and talk to me, because maybe you don't belong in honors algebra if this is a difficult problem for you. This should be a simple problem. Okay, now I'm going to divide to undo the multiplication. I'll divide by the number that's attached, by 2. Okay, and x will end up equaling 4. And there you go. It's that simple. All right, here's 4 quick examples. I will go through them really quick. This first one I won't talk a whole lot about. I know Saddam's going to tell me to undo the subtraction first. And notice how I'm showing this work. I know some of you that are in 7th grade, you asked me in Miss Pompili's room last year, do we have to show work? You see the work I'm showing? Yes, you need to show this work. Okay, you don't show the work and you get the wrong answer, you get no credit for the problem. All right, make sure you're showing the work. Okay, now on this one, I have to get rid of the 5 first, but I'm not going to add 5 because the 5 is not being subtracted. It's a positive 5, right? So it's being added to the negative 3x. So I will subtract 5 from each side, leaving me with a negative 3x equaling 30. And then I will divide each side by negative 3. X will equal negative 10. And there we go. By the way, it's just a coincidence that the first one was 10 and the second one was negative 10. That won't always happen. All right, this one here, the first step should be simple, leaving me with x over 4 equals 10. Now, to undo the division, I am going to multiply. And this should look very familiar, multiplying fractions. Those will cancel, leaving me with an x equal to a 40. Okay, and problem number 4. Again, I'm going to get rid of the negative 7 first. This time I'll add 7. Oops, not add 4. I will add 7 to both sides. And I'll end up with x over 5 equals 42. And to undo the division, I am going to multiply. I multiply by 5 over 1 on one side, by 5 on the other side. Remember, 5 over 1 and 5 are the same number. I don't have a fraction on the right-hand side, so I didn't use a fraction. All right, I'll get x. And I believe this is going to turn out to be 210. All right, by the way, you could check your answers by substituting x back into the original problem. I'm going to stop the problem here. I will get a few more extra practice problems for you together in another video if you need a little help with this. All right, Mr. Lawrence signing off. Good night, everybody.